Lesson on drawing Bohr diagrams and simplified Bohr diagrams. The Bohr model tells us that every atom has a nucleus which contains protons and neutrons, and also there are electrons that are in orbit around this nucleus. We look at the periodic table to tell us how many protons and electrons there are. In particular, we look at the atomic number. This is helium. So for any given atom, we can draw the Bohr diagram which shows the electrons in their orbits. Now each orbit has a limit to how many electrons it can hold. The first orbit can only hold 2 electrons. The second orbit can only hold 8. If we have 3, then it's 2, 8, 8. And if we have 4 orbits, then the total number in each orbit are 2, 8, 18, 8. Notice that the last orbit can only contain 2 or 8. These numbers show the number of electrons that will fit in each of the orbits. And this 8 being the final orbit is known as a stable octet. So let's try drawing some Bohr diagrams. Let's look at carbon. Its atomic number is 6. What that means is its first orbit can hold 2 electrons. The second orbit can hold 8, but because it has a total of 6 electrons, then the final orbit has 4. Let's do another one, keeping the orbits in mind, that the first orbit contains 2, the second one 8, then it's 2, 8, 8, 2, 8, 18, 8. Let's try drawing aluminum, which has an atomic number of 13. So the first orbit has 2, the second orbit contains 8, final orbit contains 3. We can also write it like this, with numbers 2, 8, 3. So this is the Bohr diagram, but this is the simplified Bohr diagram with just writing the numbers of electrons. Let's try writing chlorine, shall we? So chlorine has 17 electrons in total. That means its first orbit contains 2 electrons, the second orbit contains 8 electrons, and the final orbit contains 7 electrons. That's the Bohr diagram, and we can write the simplified Bohr like this. I'm going to demonstrate calcium now, which has an atomic number of 20. So that's 2, 8, 8, and 2. This is the Bohr diagram, and here is the simplified Bohr. It all adds up, all the numbers add up to 20. Let's do an example of a really big one like barium, which is 56. So what do we do now? That would be 2, 8, 8, 18, 18, and 2. And magnesium is part of the same family as barium. It's 2, 8, 2. Notice that they have the same valence shell. Here's a cool pattern on the periodic table I would like you to notice. Remember our pattern of how many electrons fit in each shell. 2 in the first shell, 8 on the second shell, 8 in the third shell, and the pattern for the fourth shell is 2, 8, 18, 8. And pay attention to those numbers. 2, 8, 8, 18, 8 for an even bigger atom. So take a look on the periodic table and notice how many elements are in the first row, the first period. There's 2 elements. And there's 8 elements in the second row. And there's 8 elements in the third row. And there's 18 elements in the fourth row and 18 elements in the fifth row. So notice that the number of elements in each period tells you the maximum number of electrons in orbit. So the steps to drawing a Bohr diagram, let's go over them. Number 1, we look at the periodic table and find the atomic number. Suppose our atom is fluorine and the atomic number is 9. Then we draw the electrons, remembering the pattern of 288, remembering that rule. So fluorine, the first orbit would contain 2 electrons and the second orbit would contain 7. That adds up to 9. And the simplified Bohr, you just write the number of electrons, 2 and 7.